Some of these you may have seen before. A man by the name of Mauritius Escher. He goes by M.C. Escher. He's a Dutch artist. Is known worldwide for his tessellations as well as some other things. His artwork. This one, let me see if I can blow it up without losing the resolution here. I guess you can see it here, but can you see the black geese flying to the left and the white geese flying to the right there? Here's one. He's got orange horsemen galloping to the right and white horsemen galloping to the left, and there's no gaps or overlap. It's a pure tessellation. It's just not a regular, not a regular polygon. Let's look at. Here are some white beetles traveling north, and in between them are some tan or brown ones going the same direction, but staggered. I like this one here. It's called Angel Devil. Can everybody see the angels? And interspersed with the bats, which are supposedly and no gaps or overlaps. Pretty cool stuff. This is all from Escher. What do you see here? Crabs. Do you see the dark ones and the light ones? Okay. This one here, entitled Fish and Bird. He's got the birds there are green and blue ones, as well as green and blue fish. And so this isn't a pure tessellation because we've got two shapes. Okay. Different design. What does that look like? Fish. How many different ones do we have here? Two. We got our donkey, our horse, and the fish. What's this?
It's like a tadpole.
Tadpole. Turning into a frog. It's almost lost its tail there. Again, there's these birds going two directions. This one's a pure tessellation. He's just colored it 4 different colors. This one here is a, what, can you see it? Lizard. We call it a reptile. because it's tiled and it's repeated. A reptile. Okay. This one here, we need to. This one he's turned into an art form as well as a tessellation. So you see these 3-dimensional sphinxes coming around here. They turn from 3-dimensional into 2-dimensional down on the plane. And as they come into the mirror, notice there's these white ones coming back the other direction as the dark ones are going in. And so they turn and the dark ones are going in and the white ones are coming out. And anyway, some pretty neat stuff he's done. Here's a tessellation right here in the middle. You see the white swans and the black swans. And you can even see in the space where the swan is not, it's swan-shaped. And some of you may have studied about in previous math classes a very interesting phenomena called a Mobius or a Mobius strip. I've heard it pronounced both ways. It's a strip that you take a strip of paper, make a half a twist, and then you bring it around and tape it together. And then it becomes a belt with only one side to it. And engineers have actually taken that idea and put it onto belts like under your engine of a car. And since it only has one side, it doesn't abnormally wear on one side more than another. Anyway, and he's turned it into a tessellation as well. Here's the reptile one a little bit better. That you can see here we've got our two-dimensional reptiles, and as they get to the edge of the paper, they become three-dimensional, crawl up out of the paper, become three-dimensional, crawl over here, and crawl back into the paper. And so, pretty cool. But notice how the reptiles, no gaps, no overlaps between those lizards. Seahorses, again, a pure tessellation, just one shape, but how many different colors? 3. We just had the 4th of July, this could have been This one, he's actually got a transformation going on as well as a tessellation. So, down here we've got ocean, but that ocean turns in as we move up into a, what? A bird. And the bird is then surrounded by sky, but that sky, as we come down, morphs into a fish. Kind of a cool... So he's got a transformation happening as well as a tessellation going on. Kind of cool stuff. Another one of his. This is one of my favorites. Not pure, but can you see the one kind of shell, then the other kind of shell, and then the starfish? Makes a really pretty tessellation. Now this isn't a tessellation, but some of you have seen these paintings or diagrams. You'll notice that the water falls here, and then it runs down here, runs down here, runs down here, runs down here, then falls. It's kind of a little perpetual motion machine. So this right here could be tied to a generator, and you'd get all kinds of power. Tim, come on, don't give it away.
No, the fact that you said perpetual motion.
That's the clue that this cannot really exist. If you try building this, as you watch it, see the water starts running here, and you watch it run down here, and it runs down here, and it runs down, and it looks like it's running down, and then it falls. And how could it keep going down? Anyway, try building something like this. You find it's impossible. Well, those are some things that Escher has done, and in preparation for what you are going to do, because you are going to be creating your very own tessellations. And some students get to this part and they just go crazy. They just have so much fun. Because when you get all done, you have something that's very cool looking. And we're going to show you how to do that today. This PowerPoint is available on tonight's homework, so you do not need to take notes on this because it's all available there. There are different kinds of tessellations. Every tessellation that you will build will have two things. It will have a specific starting shape, and then once you get that starting shape, there is a certain procedure that you will do on it. One or more of the transformations that we've learned about. So a type of transformation that you will do on the shape that will turn it into maybe a reptile, maybe a seahorse, maybe a whatever. And you're saying, oh, I could never do one like that, and yet you're going to see they're not that difficult. Okay, we're going to start off with the square. That's going to be my starting piece, and I'm going to perform this, create this tessellation piece by translating. So it's a translation tessellation on a square. So we start with a square, we create a shape on one of the horizontal sides. Doesn't matter whether it's the bottom one or the top one. We then translate. What's the other word for translate? Slide. We slide that shape that we've created on the horizontal side to the opposite side. That shows you that we could have created it on the top and slid it to the bottom. Does that make sense? Okay. So then we create a shape on the other side. You see the dotted line here? And we translate or slide that shape to the opposite side. You'll notice the part that was the throat here becomes the wing, right? You see the figure starting to take place here? By the way, this is one of Escher's, and this is how he did his tessellations. Then what you do, once you've got that done, is you decorate the piece. By decorate, we mean you put in the eye and the stripes on the mane and the stripes on the wing. And then you duplicate that piece. Not only duplicate, you duplicate that, and then you take those two and duplicate them, right? Does everybody see what I'm talking about? Until you have filled, it could go on forever. And if you build it the way I just showed you how, it will tessellate, there will be no gaps, and there will be no overlaps. So if you'll take the horizontal piece, slide it, take the vertical piece, create it, slide it. If you do that, your individual tessellation piece will tessellate with others just like it. Okay? Well, there's the translation on a square. Here are some student samples of students that have created those using that particular method. Notice that they've given names to their kind of helps you see what it is that sometimes a little better. And okay, can you tell that they were created by translating on a square? Can you see what the shape that got slid up or got slid to the right was on each of these as we look at them?
So the shapes themselves can just be abstract and the decoration?
Yes. You'll notice that on this dog prints, it's the decoration that made the cool thing, right? All they did was take this little wavy shape and slide it over here to make this wavy shape on this side. This kind of curly S shape here got slid up, or maybe he made it up here and slid it down, I don't know. Well, when you get done doing that, you don't see a dog, do you? The thing that made the dog was the nose and the eyes and the ear and the mouth and the tongue there. When you get done with it, sometimes it doesn't look like anything. And you go, well, what could I make it look like? The hardest part sometimes is the art part, not the math part. I'm showing you the math part. The art part could be the most challenging. If you're creative, that's the easy part. If you're like me, that's the hard part. Okay. We don't always start with a square. This time we're going to start with a hexagon. But we're still going to use the translation. So what do? Step one, we create a shape on a horizontal side. We translate that or slide it to the opposite side of the hexagon. We draw in on one of the remaining sides a shape. And what do you think we're going to do next? Translate it, slide it to the opposite. Step 5 is create a shape on one of the two remaining sides and slide it. Okay? Again, you could have created it on the top and slid it down. You could have created this shape here and slid it to the left, and so on. But now since it's a hexagon and we have 6 sides, you're going to create 3 different shapes and slide them all to the opposite side. When you do, you end up getting a shape that has no gaps or overlaps. It will fit perfectly. But you'll notice, sometimes it's hard to tell what that's going to become. It's the artwork that kind of brings out the personality and makes it fun. What happens if you get here and you go, I don't even have a clue what to turn it into? I don't know what to decorate it like. What do you do then?
Have fun. Ask a roommate.
Ask a roommate. Ask a spouse. Ask your 3-year-old brother. No, your brother or sister. Actually, since we're going to be creating these online, I could actually go up here and say, I don't know what this looks like. I could grab one of these shapes and just change this shape right here. And as I change this shape right here, it will automatically change the one over there because it got translated there. So all I've got to change is the pre-image, and my image gets changed. And so just by playing around and tweaking one of the pieces, it might finally, oh, now it looks like something. I can turn that into something. We'll show you how that works in just a moment. Okay, here's some that were created from hexagons by students. Can everybody see how they used to be hexagons? That this here got slid up to there. Do you see that curve? The 2 points here got the 2 indents at the top. And then this curve got slid up to this curve. So we got the 3. Okay. We could start with a hexagon and not do a translation. We could do a rotation. Let's look at this one. Oh, by the way, do you have to do one of each of these? No. How many do you have to do? 2. And I'll make some recommendations as we get near the end about where to start, because some of these are easier than others. Okay, start with a hexagon. On one side, any side, it doesn't matter, create a shape. Okay? Rotate that shape 120 degrees about an end point. Why 120?
Because it's a factor of 360.
Factor of 360, and why is that? Why would that be important, Megan?
Because then we talked about it last week. Because it fits around the circle perfectly with no gaps or overlaps.
And what are we going to want to do with this piece when we get done?
Rotate.
Tessellate a plane with it, right? There's another reason why it's 120. Anybody? Yeah, Shannon?
Is it because it's 60 degrees and you want to rotate it twice? Each angle is 60 degrees because it's a hexagon.
How big is each angle? What shape is this we're starting with? Hexagon. How big is each angle on a regular hexagon?
60 degrees.
Well, we better back up. How many sides? 6. 6 minus 2, right? times 180 gives us nobody has calculators? There we go, we got a few out here. Gives us a grand total of how many for our interior sum? 720, and there are 6 of them. Divide that by 6, we get 120 each. That's the main reason why we want to rotate it by 120. Okay? All right. Step 3, create a shape on a consecutive side. So we've made one, rotated it. We keep moving around the hexagon. And as we do, then we've got a third side now that we've created a shape on. Notice the shape that was created on side XG doesn't look anything like the one on side SI. Right? We take that one that we just created on XG and we rotate it 120 degrees about the open end and not the end that it's coming from, the direction we're moving. We're going counterclockwise around that hexagon. Okay? Step 5, create a shape on the consecutive side, ON. And what do you think we'll do with that? Rotate it. So you make 3 different shapes and rotate those 3 shapes. And some of you are saying, hey, I've seen that somewhere before. And this is how he did his tessellation with the reptile. But you'll notice he decorated it and colored it. This is a black and white picture, but we have a real dark one, a white one, and then kind of a gray one. If you do it right, like I've showed you with these steps, you will always tessellate. No gaps, no overlaps. So if you find yourself having gaps and overlaps, there's some problems. We'll talk about what some of those might be. Here's a student sample that's used a hexagon with a rotation approach. Okay, now we're going to start with a triangle and do a rotation. So we have an equilateral triangle. We create a shape on side FI. We rotate it 60 degrees. Why 60 now? Interior angle of an equilateral triangle is 60. Okay? Now wait a minute. On the hexagon, we created, rotated, created, rotated, created, rotated. What are we going to do now? Good. Let's look. There's only one side left. You find the midpoint of the open side, the one that doesn't have any shapes on it. You draw a shape on one half of it. So you find the midpoint, S, and then you make a shape from that midpoint to either end. You can either go to H or go to F. It doesn't matter. Okay? Then, step 3, you'll take the shape you drew on SH and you'll rotate it 180 degrees about that midpoint of FH, and that completes our tessellation. You decorate it and tessellate. Now, what we haven't been talking about is this. Let's go back to that one. Okay, let's just say I built this white one first. How am I going to get it without creating another one exactly like it? I've already got it created. I need to use it. How am I going to get this white one to become these other ones that are found on this plane here? Does anybody have any ideas? Aubrey?
I'm not sure if this is what you're looking for, but in elementary we would just cut it out and then just trace it a bunch of times on the paper.
Okay. cut it out and trace it. So if we had a piece, we could cut it out, stick the tail inside the, what'd you call that? Not armpit, leg pit? I don't know. Whatever. And then trace it, right? If we were doing this by hand, that's what we would do. And in the past, I used to do them all by hand. When the software became available, the Sketchpad, we went to having them do one with the Sketchpad and one with by hand. And it turns out you learn so much more doing them with the software that we're doing both of them that way. So, my big question would be, I've got this software, what am I going to do with this white one to turn it, get it into these other positions? Does somebody have a thought? Yeah.
Couldn't you just do the same thing, but like copy the shape and then rotate the shape? Until
Rotate it. About what? How far?
Maybe you'd have to
Where?
find
Yeah.
the center of the lizard.
So, center of the lizard, like right in here somewhere?
Yeah. Or like, could you draw the hexagon around him so that he's like in the hexagon? I don't know if that makes sense.
Okay.
Find the center of the hexagon and rotate the lizard like that.
All right. That would just make him be looking a different direction. But I've got to get him to be out here and down here and this one. And Emily, did you have your?
Well, we had talked about finding the interior angles of the actual, like, shape. And so if we found the interior angles and then figured out how we needed to rotate it, the degree we needed to rotate it, and then just keep on copying them and rotating them from one another. Does that make sense?
Well, let me just give you a hint here. If I selected this point as my point of rotation and told this white one, select the white one and say rotate it 120 degrees, it's going to turn into this light gray one. And then I could select the light gray one and select that point as my point of rotation and rotate him 120 degrees counterclockwise, and he would turn into the dark gray one. Does everybody see that? So I could create these three by doing that with the software. Now, how am I going to get this one over here?
There's the feet of the back foot on the white one.
The back foot
Yeah,
of the white one.
right there, all 3 feet right there.
Ah, all three back feet right here. So I could let that be my point of rotation. Rotate this 180 or 120 degrees clockwise, and it would turn into this one. You see what Sherry's saying? Okay, and then I could take the dark one, select that point again, and rotate it 120, and I would create this gray one, which, no, these are the ones we have down here. So now I've got this one, this one, this one, this, and you just keep going out and doing that, and you'll fill the whole screen of your computer. Okay? Does everybody see where we're headed with this and what we've got to do? Let's just say that I created this white one. Here's my original. It's just sitting there. How would I get these others? Anybody have any ideas? I've got one white bird sitting there. How am I going to get it to fill the plane?
Wouldn't you just kind of rotate it in 360, make a circle, and then just kind of...
About what point? Can you,
The tips of the wings.
Jeff, what was?
The tips of the wings.
So if I take this white one and go out here to the tip of the wing, can everybody see that if I took this bird and rotated it here, it could turn into this gray one? How far? 60? How'd you get 60? Because there's 1, 2, 3, 4, 5, 6 around that shape. So if we just chose that point, we could rotate the white one, it would become this. Rotate the gray one, it would become the new white one, gray one, and then I'm going to have all of these around here. Then how am I going to get these out here?
Start with the other.
Start with this wingtip and start going, yep. Good. Now, one thing I should tell you is do your decorating and coloring before you tile your plane. After you've got your one figure, your pure tessellation, the one thing you're going to tile the plane with, decorate it first. Why? They may not be uniform. These three stripes on this wing may look different on this one because as you decorate them, you might decorate them differently. And we want them to look alike. There's a more important reason than that. You what?
You'll get confused easier if you don't have it the way, because then you can see it rotating better.
Possibly. I'm thinking of a much more
It's just gonna save you a
logistical.
lot of time,
How?
because then you're not having to do all those.
Then I don't have to go and make eyes for every single bird and feathers for every single bird and color every single bird. And on Sketchpad, coloring is a huge task. So you want to color one, and then all you have to do is click inside, for those of you using Sketchpad, and you just change the color. Whereas if I were to have to make a color on the color the inside, it is so tedious. But do it once, then just change the color. It's much, much faster. So it's a time savings as much as anything else. Okay. Start with a rhombus. And we're going to do a reflection tessellation. Okay. Create a shape on one side, side PI. Reflect that across the diagonal. Okay. Then take the one you reflected from PI to PF and rotate it about F 120 degrees. So that this point right here on this shape is now found right up in here. Do you see the point? And this little point going in is now this one coming out as we rotated that 120 degrees. And then we take that piece we rotated and reflect it back across the diagonal. What does that say? Rotate. That's wrong. That should say reflect that piece down here. How did that happen? I have to change that. Change that real quick here. Caps lock is that piece across the diagonal. There we go. Okay. Now, let's go back. If you do that, there will be no gaps or overlaps. Okay? Everything will fit together nicely. Now stop and think. If I were to have built this Oriental fellow, rice farmer, I don't know, what do you want to call him? How would I get him to turn into this white one and this dark one and this, I mean, what would I do?
You rotate it, but you do a little bit more because you have to skip it. So
Rotate it about what point?
So
I've got this gray one.
120.
Huh? Where's the point I'm going to rotate it about?
Yeah, tip of the hat.
Tip of his hat. If we put that as our point of rotation and rotate him how much? How many degrees? 120 either clockwise or counterclockwise. I could get him to be this white one or this dark one, right? That would give me these three. Now how am I going to get these other ones around them? See, this is what your plan is going to be once you get doing this. You're going to have to figure out what to do with them to get them to turn into... Well, can you see once I've got this gray one turned into this white one and this dark one by rotating them about that point? I could pick this point on the white one that I've now got, rotate it 120 degrees clockwise, and it'll turn into this dark one. Can you see that? So there's more than one way of doing these things, and however you see it and get it to happen is great. Okay, what about starting with a triangle and doing a reflection? So we make a shape on one side, okay? We reflect that shape about a line parallel to the base PL midway between the base and vertex E. I should put it in 2 steps. I haven't done this. Okay, so we've got base PL. There's a line parallel to base PL. It's midway between the base and vertex E. So we make a line right here. Okay? And we translate we reflect it about that parallel line. So I've got this line, and I take this shape right here, and I've got a line going right here. This piece gets flipped. So what's up here becomes down here. What's up down here goes up there. And then we slide that piece over. So it's a flip of this and then slide. Can everybody see that? Okay, a flip and a slide. Then on our last remaining side, we find the midpoint, connect it to one of the ends, and rotate it 180 degrees. You can do the dotted one and rotate it into the solid, or make the solid and rotate it into the dotted. And there's your piece to decorate, and then you tessellate with it. And if you do these procedures, it will always tessellate with no gaps or overlaps.
Are you going to show us an example on GeoGebra? Because online there's only a video for Sketchpad.
We'll have that in the directions available to you.
Okay.
This first tessellation, there's a homework assignment tonight called Tessellations, creating your own tessellation or something like that. But the actual first project isn't due for a week. And it's due, I think, at midnight a week from today. So that means you can come to class Thursday and ask some questions, or come to my office and ask some questions, or even next Tuesday and ask some questions to get some help on it. And we'll get this is the first time I've done it with GeoGebra, so we'll get the GeoGebra material all out there as well. Okay. Here's the student sample doing it that way. Now, here's your assignment, your assignments. Okay, so there's the regular homework assignment, and then there's 2 separate tessellations. One's going to be due a week from today, and the other one is due, when is it? It's up there. I think it's the following Friday at midnight, if I remember right. So, what will you do? You're going to create 2 different ones. Each will be created using Sketchpad or GeoGebra. You have your choice. You may choose any 2 of the following tessellation methods we illustrated. Translation, rotation, reflection. Do not do 2 of the same kind. Okay? The starting piece may be the same as long as you use 2 different methods. In other words, you could do a translation tessellation based on a hexagon, as well as a rotation tessellation based on a hexagon. So you can use the same starting piece, but you can't use the same method. So you can't even use a square and do a translation, and then do a hexagon and do a translation. That's not, you'll get docked for that, big time. Because I want to be able to see you use more than one method. That's why I don't care if you use the same starting piece, but two different methods. Okay? We're providing you with not only some samples, some examples, but also some step-by-step instructions. Okay? So some of them will be step-by-step instructions with an example, and some of them will be step-by-step instructions with just written out. Do this, then do this, then do this, then do this, and it will walk you through that. So as you watch the example that's been created and look at the written examples, and then videos will have that. So here's how we're going to grade it. For each tessellation, you must state what your starting piece is, and these are going to be done in steps. Okay? And I don't just want to see the final piece. I want to see, remember I showed you step 1, step 2, I want to see each of your each stage of your tessellation as it moves along. Okay? And the very last thing I'll see is the tessellated piece decorated. And the one I'll see right before that is the one that you have decorated up. Okay? So, here's where your points come from. Each step done on a separate tab. Tab, this is referring to the sketch pad. We'll be talking about a separate file here where each one gets added onto. Okay? Here's where the big points come. This is the math. Each step is explained thoroughly and mathematically on each tab. The individual tile actually tessellates the plane. Now, the only reason that wouldn't happen is if you didn't follow the procedures properly, or if you start with the shape you make. You've got to build yourself. If you're going to start with a square, you can't draw a square, you must construct a square. Does everybody know the difference? If you draw a square, your starting piece, and I can reach up with my mouse and grab one of your vertices or sides and I can deform it so that it's not a square anymore, then you didn't construct a square. Now, I can be able to go grab a vertex and make it a bigger square. No problem. All that will do is it will make your tessellation get bigger. And what's fun is you can do that at the end. You can actually take that figure and you can, as you do it, that piece that has all the different things on it will expand, and the things around it will do the same thing, and it still stays tessellating. Okay? So make sure your starting shape is a constructed equilateral triangle or a constructed regular hexagon. Because if it just started that way and looks like it, but I can grab a side and deform it so it's not a regular hexagon anymore, then you could have trouble down the road. And you may not actually, it may have some gaps and overlaps. Okay? Detailed explanation about how each individual piece gets transformed to get it to tile with the other pieces. So you will say, I took this point as my center of rotation, I rotated my original piece 120 degrees, that made this and this, then I did, and let me show you how that works. And that's 140 or 70 points, this totals 70 points, there's 2 of them. And then you've got to make sure you've used different methods. So let's quickly go to an example. And let's see here. This is a sketchpad example, but we're going to have one up there for you too. All right. This is what we mean by tabs. So your first piece will have the starting piece, and you're going to tell about that starting piece. This tessellation is a reflection tessellation. I'm telling you the method I'm going to use. And it's based on the rhombus as its starting figure. That's really all you need. This is some more is directions here for you. Then down here are these tabs. Notice step 1, I tell what I did. In this step, a design is created using segments to connect two of the adjacent sides. Notice that the part of the segment design is, part of it is located inside the rhombus and part is located outside. Okay? Step 2, what do? I construct the long diagonal, mark it as the line of reflection, and then all the points and segments are selected over here and get reflected across here. So I let the software do all of the work once I've made that initial shape. Just reflect it. Step 3, I rotate this one down here, down to this, and then finally take this piece and reflect it across here. And then what do? Okay, I tessellate, and there should be one in between there, and that's decorate the piece. Okay. On this one, I actually tessellated, and that's how I know that. And you might notice that the mouths are maybe a little bit. In fact, this one doesn't have a mouth. See. Because it takes a long time to do those. But if I want to change color here, I'll just show you this. I just go up here like this and say, display, go to color, and make that yellow. But doing that for each one of these is a pain. So color it first, and decorate it first, and then. Okay? So, which one should you start with? My recommendation is the shape is not important. If you're really, really nervous about this, you're worried about this assignment, pick the translation, one of the translation ones. Okay? And do it for your first one, because it's a little bit less rigorous mathematically and design-wise. Start with a translation, a slide one. There was a square. You could do a square. You can actually do it on a rectangle if you want. You could do it with a hexagon. But a translation is an easy one. Those of you who are looking for a challenge, start somewhere else. Those of you who want to start with something easy, start with a slide, a translation. Okay? Get going on it. Everyone should be started with something playing around with by next class so that you can ask questions about it. And I'll